let's have a look at sampling methods. So we've got a number of methods here which are really good sampling methods, and the reason they are good methods is because they choose students randomly. Everyone's got this equal chance of being chosen. So a simple random sample, this is when every person's got the exact same chance of being chosen. It's like names out of a hat. You just chop everyone's names up, put them in the hat, and pull them out at random. The next one is stratified sampling. So what happens there is we take our population and we separate them into groups of some description. And then within each group, we take a random sample. Okay, so I might separate the students out into males and females. And then within the males, I'll take a random sample of 10 males and a random sample of 5 females. Okay, so that's our stratified. Cluster. This is often, clustering is when we talk about locations. So for example, if I'm talking about houses, there'll be lots of houses in one area and very few houses in another area. If I'm talking about schools of fish, going fishing, the fish tend to travel all together in a school. So if I catch one fish, I'll catch lots of fish. And so I will just keep sampling at that same point, and I go to a different spot, go fishing, no fish, and I'll just move on to the next one. So when we have people or animals grouped together, that is called cluster sampling. Systematic sampling, that's when we have a system to take a sample with. So I might get everyone to line up, and I'm going to start randomly at person number 2. And after that, I'm going to take every third person in the list after that second one. And that is how I would choose my random sample. So those 4 methods are all random sampling methods. They're going to give us representative data. Okay, then we've got a couple of non-random sampling methods, so convenience sampling and self-selected. So convenience is, as a teacher, I'm just going to say to the person closest to me, can you please go down to the office? Okay, that's a convenient sample. I'm just choosing something that's convenient to me. It's not random. People do not have the same chance of being selected. A second one is a self-selected. So this is when we ask for volunteers, and I might say, right, can I have 5 people to run errands for me? And those that volunteer could be different, and they've got a different chance of being selected than those who did not volunteer. So what I've got here is I've got 6 different scenarios, and we need to work out which one belongs to, as an example of which sampling method. Okay. So the first one, Mrs. Sneddon prints out her Stats 2 class list. She randomly starts at the 10th person on the list and then chooses every 4th person on the list. Alright, so that is a systematic. I'm starting at person number 10 and then I'm choosing every 4th person after. So that is our systematic sample method, systematic sampling. The next one, at assembly, Ms. Patience asks students who want to take part in the blood drive later this year to stand up. So if students are doing the blood drive, they are volunteering to do that. So that is going to be our self-selected sample. Students choose themselves. Okay, so this is a biased method. And the systematic is a random method. So, Mr. Singh needs help setting up the pods for an assessment and asks the 5 students seated at the table nearby to help. Okay, so he's just asking the 5 people nearby, so that is our convenient sample. And that is a biased method. And I can't spell convenience. There we go. Okay, another one down here. Mr. Chandakay is organising the calc students into test rooms. He separates his class into one pod and Miss Al-Salihi's class into a different pod, and then chooses 2 students randomly in each pod to help hand out spare paper. Okay, so he's separated out this group of students. He's got a great big group of students all standing outside ready for their test, and he separates them into the 2 classes, his class and Miss Al-Salihi. So therefore, this must be, if you look at our different methods there, this is going to be our stratified sampling method. which is a random method. Okay. Mrs. Moss was doing a survey of students' opinions in the canteen. So she walked around the school, randomly choosing students in each commons to ask them some questions. So she's gone to each commons, and if I think about the way that the school is laid out, there'll be students, lots of students within the commons, and there'll be other areas where there's no students at all. Okay, so this is an example of our cluster sampling. Okay, and the last one, Miss Albertson is doing an experiment with her Stats 3 class and needs to decide which students are going to throw a ball with their left hand and which are going to throw with their right hand. She tosses a coin for each student, and if it's a head, they'll throw with their left hand, and if it's a tail, they'll throw with their right hand. Okay, so each student is tossing a coin. So this is a simple random sample, which is a random method. Okay. Now, let's have a look at this next question. Describe how you could take a simple random sample from your Stats 2 class using a dice. So, simple random sample. So the simple random sample, if I go back up to the top, that's this one here, where everyone's got the same chance. It's like pulling names out of a hat. Okay, so the tool that we've been given is we've got a dice, and we want to take a random sample using that dice. Okay, so it might be that I could say I get each student to roll the dice, roll the die. If it is a 1, then they will be in my sample, otherwise they won't. Okay, so every student has a 1 in 6 chance of being in my sample, so they've all got the same probability. Number 3, describe how you could take a stratified random sample from your Stats 2 class, separating by gender using a coin. Okay, so stratified, we're separating by gender. Okay, so that's my first thing I need to do. Separate the class into a line of males and females. Okay, so I've got my 2 groups. Now I need to select a random sample from the males within that, and I need to use a coin to do that. So give each male a coin, and if they toss the coin and get a head, then they will be in the sample, and repeat this for the females. Okay.